Hello students, welcome to the course on Basic Electronics Engineering and the course code is EC101. This is the course for BTech first semester CSE, IT and FT students and second semester ECE students. Myself, Dr. Surojit Bosak, Assistant Professor of ECE Department, Guru Nanak Institute of Technology, Kolkata. And this is my official email address. Today, we are going to start lecture number 1 from the fifth module, Feedback and Operational Amplifier, with the topic of feedback amplifier. And the lesson objective of this topic is study the concepts of both positive and negative feedback in electronic circuits, and this topic is mapped with CO number 3. So let us start lecture number 1 from the fifth module, feedback and operational amplifier, with the topic of feedback amplifier. So what is feedback amplifier? Or what do you mean by feedback? The process of injecting or feeding back a fraction of the output energy of a system back to its input is called feedback. So feedback process significantly alters the various parameters of an electronic circuit, such as input and output impedance, voltage or current gain, and bandwidth of an amplifier. So this is the figure of a feedback amplifier. So see here, some energy or some output energy of a signal is just feedback to the input. This process is called feedback. With the help of a feedback network is present. So the feedback signal, see, the feedback signal can either aid or oppose the input signal. So feedback signal either can be added or it is subtracted with the input signal. That is why a plus minus sign is present. So depending on this feature or depending on the relative polarity of the signal being feedback into a circuit, the feedback signal can be of two types. One is called positive or regenerative feedback and other is called negative or degenerative feedback. So feedback amplifier is two types depending on the relative polarity of the feedback signal. One is called positive feedback and other is called negative feedback. Negative feedback is called degenerative feedback and positive feedback is called regenerative feedback, and which is used mainly in oscillator, and negative feedback is used mainly in amplifier. So first we discuss about positive feedback amplifier, then we move for the negative feedback amplifier. If the input signal It may be voltage or current. Increases in magnitude on application of the feedback signal, then the feedback signal is in phase with the input signal, which is known as positive feedback. That means the overall signal amplitude is increased. So it is increases in magnitude and is in phase component with the input signal. Feedback signal is in phase component with the input signal. The amplifier produces a phase shift of 180 degree, and the feedback network also produces a phase shift of 180 degree. So overall phase shift is 360 degree. Around the feedback circuit causes or the resulting feedback voltage to be in phase with the input signal. Positive feedback increases the gain of an amplifier. It also increases the distortion and instability of the amplifier. Distortion and instability are also increased by the positive feedback. So positive feedback generally used in oscillator, not in amplifier. Negative feedback is used in amplifier. So if the positive feedback becomes sufficiently large in magnitude, it leads to oscillation, and oscillation converts DC power into AC power of any desired frequency. So this is all about positive feedback, which mainly increases the magnitude. That means feedback signal is added. Next is the negative feedback. Now, if the input signal is reduced in magnitude on application of the feedback signal, that means the feedback signal is out of phase with the input, then the type of feedback is negative feedback. In this case, the amplifier introduces a phase shift of 180 degree into the circuit, while the feedback network introduces no phase shift. So consequently, the feedback signal is 180 degree out of phase with the input signal. So this type of feedback leads to stabilization of gain, increase of bandwidth, reduction of distortion, and change in the input and the output resistance. So ultimately, it's a negative feedback means it reduces the magnitude and it is out of phase, because amplifier introduces a phase shift of 180 degree, but feedback network does not have any phase shift or zero. It produces a zero phase shift. So that is why it is out of phase. And negative feedback mainly used in amplifier. So this is a general feedback circuit, and we want to introduce some basic concept and principle of feedback amplifier. The basic block diagram of a feedback amplifier is shown here. A feedback amplifier is also known as closed loop amplifier Why? As a closed loop is formed between the input and the output of the amplifier. Essentially, two blocks are there: a basic or internal amplifier and a feedback network or feedback circuit. In a feedback amplifier, the output signal is sampled and feedback to the input to form an error signal that drives the amplifier. In order to derive the basic feedback equation, certain assumptions are made. What are the assumptions? The first assumption is reverse transmission from the amplifier output to the input is 0. So reverse transmission should be 0. That is from the output to the input of the amplifier. And second is the forward transmission through the feedback network is 0. So the feedback network contains passive circuit elements like resistor, inductor or capacitor, and active elements like transistor. Now, what is the open loop gain? There are few important terminologies. First of all is the open loop gain A, or transfer gain of the internal amplifier. The transfer gain of the basic or internal amplifier, say A, is basically V0 by Vi. See in the next slide. So the open loop gain or transfer gain of the internal amplifier A is equal to V0 by Vi, where Vi is the input voltage and V0 is the output voltage. Now, a feedback factor is also known as feedback ratio or reverse transfer ratio or reverse transmission factor, and this determines the fraction of the output signal that is added to or subtracted from the externally applied input signal. Say it is Vs. In the circuit, it was Vs. With the help of feedback network. So this is given by beta, and beta equal to Vf by V0, where Vf equal to beta into V0. The feedback voltage Vf equal to beta into V0. Therefore, the input voltage of internal amplifier is thus Vi equal to Vs plus minus Vf. That means plus sign holds for a positive feedback and minus sign or negative sign holds for negative feedback. Now the important term, what is closed loop gain or transfer gain of the feedback amplifier. So the closed loop gain of the feedback amplifier is the ratio of output voltage V0 and the external input signal voltage say Vs, and which is given by AF equal to V0 by Vs. So this is called closed loop gain. Now if Vi equal to Vs minus Vf for negative feedback, and considering open loop, we have V0 equal to A into Vi. So Vi equal to Vs minus Vf. So A into Vs minus Vf, and this is this block diagram is shows the negative feedback, where feedback signal is just subtracted with the input signal. So ultimately Vi will be Vs minus Vf. Now Vf equal to beta into V0. So V0 equal to again A into Vs minus beta V0. Therefore V0 plus the simplification A beta V0 equal to A into Vs. So V0 into 1 plus A beta equal to A into Vs. Therefore closed loop gain for negative feedback amplifier is V0 by Vs, which is basically A by 1 plus A beta. Now if we consider the open loop, that is in absence of any feedback, that means beta equal to 0. In that case, AF equal to A, where A is the transfer gain without feedback. Now, the loop gain is given by basically minus A beta, as it gives the product of the gain of the branches making up the loop, and it is called the return ratio or loop transmission. The difference between unity and loop gain, that is 1 plus A beta, is called the return difference. Now, for considering positive feedback, this is the block diagram of a positive feedback. In this circuit, the input signal Vs and the feedback signal Vf are combined in the mixture network to obtain the difference signal Vi, which is applied to the input voltage to the basic amplifier. If the feedback signal Vf is added in phase with the input signal Vs, then the feedback is called positive feedback. So for positive feedback, 1 plus A beta, magnitude of 1 plus A beta, obviously less than 1. So hence we get magnitude of AF greater than magnitude of A. But for negative feedback, where the feedback signal and the input signal Vs are out of phase with each other, therefore 1 plus A beta, magnitude of 1 plus A beta obviously greater than 1. Hence we get magnitude of AF less than magnitude of A. Now if magnitude of 1 plus A beta is 0, then basically magnitude of AF is basically infinity. Now what does this mean? It implies that the amplifier gives an output signal even when the input signal is not present. Then the amplifier becomes an oscillator. It is a very important criteria or special type of criteria. I will discuss later on this matter. Now, in decibel, the amount of feedback introduced into an amplifier is given by, so amount of feedback in dB, that is represented by F in dB, is 20 log 10 AF mod of AF by A. That means AF by A, so that is 1 by 1 plus A beta. So it is 20 log 10 mod of 1 by 1 plus A beta. Now F is negative for negative feedback. Why? Since 1 plus A beta, magnitude of 1 plus A beta is always greater than 1, and it is positive for positive feedback, since 1 plus magnitude of 1 plus A beta always less than 1. So this is the basic principle of feedback amplifier. And the next class we'll discuss on what are the different types of amplifiers are present. Okay, so let us stop here. Thank you so much.